Alright, this is a variation of an AND type problem and complement problem, where you would have to take 100% minus a probability to come up with the probability of a complement. So here we have a multiple choice test that has 5 choices per questions, and it has only 4 questions on it. So the first question is, what is the probability of getting just one of the questions right when you guess? So since there are 5 choices and only one of them is correct, your probability of getting it correct is 1 out of 5. That's also known as 20%, which is also known as 0.2. So any one of these could be written or read as the probability of getting one of the questions right. You have a 1 out of 5 chance, you have a 20% chance, you have a probability of 0.2. All right, so then what is the probability of getting a question wrong when guessing? Well, to get the probability of what is wrong, that's complete opposite of actually getting it right. So the probability of wrong is going to equal 100% minus getting it right. So in this case, it'll be 100%, and I'll stick with the percent one, minus 20%. So you have an 80% chance of getting each individual question wrong. All right. The third part here is, what is the probability of getting 100 on this test? So out of the 4 questions, you have to guess this one correct, this one correct, this one correct, and this one correct. So the key word here is and. And they're independent events because if you get the first one wrong, that has no effect on whether you get the next one right or wrong, assuming you're guessing. So when we talk about and, we're talking about multiplication. So if we're going to keep getting them right, we're going to keep having a probability of 0.2. You cannot use a percent in a calculation. So I have to go to the decimal form of it. So always change your percents into decimals by dividing by 100. So this is going to be a 0.2 chance of getting the first question right, a 0.2 chance of getting the second question right, 0.2 chance of getting the third question right, and a 0.2 chance of getting the fourth question right. And notice I'm multiplying them all together because the word and in multiple selections means to actually multiply. Now in a calculator, it's much easier just to type in 0.2 raised to the 4th power. This little caret symbol is kitty corner to, I think, the 7 on the TI-30X2S. No, it's on the right-hand side, closer to the 9. And this is going to give us an answer of, let's see here, 0.2 raised to the 4th power, 0.0016. Now remember, this is a decimal, 0016. So if we want to change it into a percent, we'd have to multiply it by 100, and this would be a 0.16% chance of getting 100 on this test. So in other words, just by guessing, more than likely you're not going to get 100. All right, the last question is the one that's kind of interesting. It says, what is the probability of getting at least one wrong? Well, getting them all right and getting at least one wrong are complements of one another. The opposite of getting them all right is not getting them all wrong. The opposite of getting them all right is one of them has to be wrong. That would be the negation of it. So all we have to do to get this answer is to take this answer from the previous question and say, well, it's going to be 100 minus 0.16%. 100% minus 0.16%. So this is going to be, what is that, 99 something or other? So 100 minus 0.16, 99.84. So the probability of getting at least one wrong is almost a certainty, almost. Now when I say at least one wrong, you can get one wrong or 2 wrong or 3 wrong or all 4 of them wrong. So you have this much of a chance of getting at least one wrong. So it's a pretty high chance that if you're guessing on this test, you're going to get a 75 or lower rather than getting the 100 because there's only 4 questions. So that's how it works with percents, decimals, multiple selections, and complements of all compared to at least one.